Okay, so you're literally some card master from an unnamed, totally not copyright infringing card game universe, faced with the following game puzzle. You have a bag of tokens as well as a power level. You can play a token face up that's at or below your power level face up. And if you do, reduce your power level by the value of your token and increase your score by 1. You can also play a token face down as long as your score is 1 or more. If you do play face down, increase your power level by the value of that token and decrease your score by 1. Given these rules, what's the maximum score you can earn? It's time to do. Just kidding. The first thing we will do is sort our tokens and cast them as a deck. The reason why we are sorting them is that our algorithm is greedy. Whenever we need to play a token face down, we want to get the maximum increase in our power level, as doing so will allow us to play the most number of tokens face up. Our loop runs so long as there are tokens still left in our deck. First, we want to play a token face up if the smallest token costs less than how much power we have left. We then play the token, removing the token from the front of our deck, increasing our power by the token's value, and increasing our score by 1. If we can't play a token face up, we need to check if it makes sense to play a token face down. It only makes sense to play a token face down if there is more than one token left in the deck. Otherwise, we would only be decreasing our score with no chance to increase it. Furthermore, we can only play a token face down if our score is greater than 0. If we do play a token face down, we need to remove the token from the end of our deck, increase our power level by the amount of that token, and decrease our score by 1. If neither condition holds true, we have obtained the maximum score we can, and now we'll break out of the loop. At last, we can return our score. Since we have chosen the optimal move at each turn, we are assured that this is the maximum score we can get. So, have we fallen into the trap of an easy-to-understand but inefficient solution? The good news is that our solution is fairly efficient thanks to the use of a deck. The biggest cost in time complexity will be our sorting, which is done in O of n log time. Thus, the time complexity of this algorithm is O of n log n. The space complexity is bounded by our deck. In the worst case, the size of the deck is our n elements. Thus, the space complexity is O of n. Consider this question solved. Thanks for subscribing, and we will see you next time.